Welcome to this tutorial about AI and more specifically about EQS or Environmental Query System. This is a system that allows us to react to our environment for our AIs, and this is what we will be going through today. So a little bit about EQS. EQS is an experimental system available in Unreal, which allows you to query, meaning to ask the environment questions, and then allows you to make decisions based on those questions, or rather those answers of those questions. So EQS allows us to do determinations for the AI, which will make it look like it is smart and making decisions. The way this is done is by creating points of interests in the world. It could be locations to move to based on information like what some pawns can or cannot see. It can be things like pickups in the world, the AI deciding if it should go for a pickup that is near an enemy or go for a safer pickup further away from that enemy. You have a lot of options for creative solutions, which in turn can translate into AI that feels more like actual players. In this, the first episode of EQS, we will touch on three different things. The EQS Pawn, which allows us to preview and debug what our queries look like in the world. EQS queries themselves, which can be used like tasks in behavior trees. And lastly, we will talk about contexts, which gives us a reference points for our queries to work around. So let's get started with the Pawn. Here we are inside of Unreal Engine 5, and this works just as well in Unreal Engine 4 as well, since the EQS system has been along for a very long time. What you need to do to begin with is make sure that you have the plugin enabled, and you do that by going to Edit and Plugins, and then you can type in Environmental, and you can see the Environmental Query Editor here, and it's experimental, and you just make sure that it's checked and restart if you need to. That's the first step. So let's take a look at the pawn that we were talking about. The pawn we will create here by creating a new blueprint, and then we will type in EQS, and you'll see that we get an EQS testing pawn. So like I said, the purpose of this is to make sure that we can visualize what our queries look like and debug a little bit about it. So we'll call this BP underscore EQS underscore pawn. And if we drag it into the world, you see that we have a little billboard next to a capsule, and that is what our pawn looks like. How this one works is that this one needs a query to run, and you set it up over here in the details. Scroll down here to the EQS part here, you can see that we have a query template, and then some other parameters which we can modify this with as well. So this is the pawn, and without the query it doesn't really do much at all. So we will now move on to a query and see what that looks like. So to make a query, we right click and we go to artificial intelligence and we choose environmental query or environment query. We'll name these EQ and then a name that describes what it would be doing. So something like, for example, find move to location is something that a query could do. If we open up the query, this is the blueprint graph that we're greeted with, and it resembles a little bit like a behavior tree. If we actually go in, make sure to save this before, but move into our behavior tree that and again, I maybe didn't mention this, but this is a continuation from the earlier AI episodes. So if you have followed them along, you should be having something very similar to this already made. We created a blueprint task for finding enemy before. So if we remove this one, just disconnect it and move it away a little bit for now. And then we drag off from this sequence, we can type in EQS, and you'll see that we get a run EQS query as an alternative. Clicking that allows us to get a task that runs a query. Now, important to note is that the node up here in the top, it is deprecated, so this is not the part of the node that we're going to be using. You want to be in the EQS part over here, and you can see here that it allows us to put in a query template. We have now created a query template, so we could already put it in here if we wanted to. and we can save it like so. We will be getting back to this later on and be creating a few different behaviors and different situations for those behaviors to make sense. For now, we will leave it as is. We go back to our query, and how this works is by dragging off the root node here, you get a bunch of generators available to you. Now, these can be used for a lot of different things. We will touch on some, but not all of them moving forward. But for now, we can start with the one that says points pathing grid. Now, what this one does is it generates a grid around someone or something, and it creates points basically. To demonstrate this, we can see here we have a grid half size of 1000, meaning 10 meters, and a space between of 100, meaning 1 meter. So if we were to go back to our query pawn here now and make sure that our query pawn, our EQS pawn, has, let's see where it is. There we have it. No, that was the mesh. Here we have the template. We can just drag and drop it here. You can see what is happening here. So by default, if we go to the query again, we can see that the grid half size is 1000 with 100 in between, meaning one every, or 10 of them per half size. And half size here is meaning radius essentially. So it's the distance from the pawn out to one of the sides. So this is 10 different points on each of these axes, but it also goes, of course, in the negative, so to speak. So we actually have 20 times 20 here now. And the way to understand this is that these are points that we will be doing queries against. And by seeing this, it's quite easily visualized that this is quite demanding on performance if we're not being careful. Because 20 times 20 of these points, and let's assume that we were to do a line trace, for example, from each of them to check if we are visible from this point to this point. Having 400 line traces every time this query runs can be quite demanding. So what you need to do when you work with queries is you need to have this sort of mantra in where you always try to filter out as many points as possible. And after that, you make an evaluation of which ones of the remaining points is the one that are the most interesting. And the general idea of this is that we are using blueprints, and blueprints do not offer as much control as C++ does. If you were using C++, you have greater control over what you want to do with your points and things like that. So you're a little bit liberated in that sense. But if you're using this in blueprints, you have to be a little bit careful. So to demonstrate a little bit about the functionality of a query, what we can do is, in addition to actually just like trying to filter it out and then scoring things or determining which ones are the most interesting, we also have the ability to actually make sure that we have a smaller grid, for example. So let's move this to the side a little bit so we can see in real time what is happening. And then we have the third person example here. So if we go in here and we type in 500, you can see that the grid is considerably smaller. We have effectively reduced it from 400 to just 100. We now have 10 times 10 points to work against. And that is one way you can keep this in check when it comes to performance. Another one is to have greater spacing in between these. So we could have 200 and you can see that it's more spaced out. If we want to, and if we move this around, you can see it updates when we move, but we have an option here to choose rerun query only when finished move and uncheck that, which will give us a more immediate response to what our query is looking like. So they are the two first basic parts when it comes to making sure that your performance doesn't tank. When it comes to this specific grid at least. Now, in addition to those parts, what you need to have a grid functioning is you need to add the tests. And you can see here we can right click to add tests. And you can have as many tests as you want, but your rule of thumb should probably be filter out things first, then score things. What do I mean by scoring? Well, if we add a test here and we say distance, what this does is it creates a test for distance and it tells us based on a criteria how to measure points on the distance. So let's go back to having 100 here to begin with, just so that we have a little bit more points to work with so it's clearer. And then we click on this test and we get the details for the test. And the test has a few different ways you can work with it. It can have filter, which is just removing points. It has score, which will give them a value to see which one are the most desirable ones. And you can also do filter and score, meaning you're doing both of them at the same time. If we change this to score, we can immediately see that we get some kind of opinion about which points are the best ones. Lower score means worse, higher score means better. In this case it will run from 0 to 1 because we have one test. If we would have multiple tests, it would be able to have a score higher than 1 because it will be adding all of the tests together. By default you can see that we have a scoring that says, let's see here, we have score over here, scoring equation, linear. So we can choose to have constant, linear, square, inverse linear, and square root. And these will all affect how our scoring will be affected over distance. By distance, we mean in 3D in this case. You could also change to 2D if you wanted, or just the height if that is what you're after. And in addition to that, we also have a context, which we will be talking about in a little moment. This is very, very important, but for now we will let it be. Then you also can add things, you can change things like scoring factors and normalizations, and also change multiple contexts here to have how the different values should be reacting with each other. Now, to demonstrate this a little bit, we can add another score, or another test, sorry. We can choose to have another one that's distance. And this time we can say, instead of score like we used before, we can use filter. And we can type in that we want to have maximum. So if we type in a maximum here that says, the range of this one was 500. So let's say we want 300 here. So maximum 300. Now you can see that everything that is at most 300 away from us is what we're actually using to score on. So these two tests are now working in conjunction. If you just wanted to see one of the tests by themselves, you could just disable one of them, and you can see that now we're only doing the scoring. And if we disable that one and enable this one, we can see we're only having the filtering. Having both of these together gives us this result. Since this is a filter, we want to have it higher up because we want to have the filters act first. In addition to that, you can also, if you wanted to have filter and score in the same property, if you wanted to make it have fewer tests, but this might allow you to more easily visualize what you're doing. And yeah, so you have these different properties on these tests, so you can tweak the results a little bit. And you have a bunch of different ways to create results which look like you're intelligent. Like Epic have this AI tutorial where they go through the system along with a lot of other things, and they show how you can have a character where you can check against an enemy's vision and then see where do you want to go if you want to hide. And we will be creating something similar later on. We'll be creating some kind of civilian that's running away from an enemy. So it would be, for example, if it was standing over here, it could see all of these points, but if this was a hostile enemy, you wouldn't want to go to any of these points. You would want to go to some of these points over here. And in addition to that, they could also check something like you want to have the furthest point, which means it would be in this point, or you could have the closest point that still isn't seen by this one, which would mean that you would run over here or something like that. You can have lots of different queries working in conjunction with each other to achieve something that makes the AI look smart. Yes, so let's start touching a little bit on contexts now. Now, the context for these specific tests over here in this query are all related to the self, the pawn over here. So if we wanted to, we could also have the query or the tests themselves be in relation to something else, like this character, for example. In this case, this is a third-person character. So what we can do is we can create a context for ourselves. So we go in here and create another blueprint class. And we can type in context. And you should see environmental query context blueprint base here. And we'll select that one. So since this is a context, environmental query context, so EQC should be a good prefix for this. And then we'll call this one enemy player, let's say. Now, if you open this one up, and let's dock this so we get a little bit more space for this. This one is a blueprint that you have 4 overrideable functions for. You can see them over here. So if you click override, we can choose to override a function that will return a group of actors, a group of locations, one actor, or one location. And depending on which one of these you use, that's what you will be returning to your environmental query that is using the context. So if we were to use the simplest one here, or one of the simpler one, which is an actor, you can see that this is what it looks like. It has a few inputs. We get the querier object, and we also get the querier actor. We also have a resulting actor, and this is the one we're interested in providing. So in this case, we're gonna use something a little bit hacky just to show you how it works. So we'll do a get actor by class, and we'll choose the third person character, and we'll just hook these up like so. So we will be returning a third person character to this, and the first third person character that we encounter in the world, and then return it to this context. In this case, we only have the AI character over here and one third person character. So this should be the character that it returns. So how does this work then? Well, if we go to our EQS query, and let's put it over here so we get some space so we can actually demonstrate what is happening. We have a few different things here. We have our generator itself, which is something that uses a context. And we also have these tests, which also are using contexts. So if we were to say, for example, that we wanted to have, in this case, we're scoring, let's disable this for now, the filter, and have only the scoring. So in this case, we're scoring the ones that are the highest away from this pawn as a result for us to have and move towards. But let's say that we are using this character as the context or reference point instead. Look what happens. This is the scoring, and we change this one from this one to the EQC enemy player. And you can see that the points that are closest to this player, or this character in this case, and it doesn't need to be a character, it can be a whatever blueprint in the world. You have complete freedom of how you want to use this, but in this specific case, the ones closest to them are the least desirable, and this one is the most desirable. So meaning this one would be the one that we run to, which makes sense if we wanted to run away from an enemy, right? In addition to that, we could, for example, go to this one, and instead of using 300 as range, let's use 500. If we change the context for this one to the enemy player, This means, if we activate it actually, like so, that we're only calculating values around this player over here as points that are possibly valid, and then we are scoring them. So you see that the context or the reference point is very important for the results of your queries. And if we were to move here, you can see that it's filling in points to display them near this character, which is the reference points we're using in this case. So that is how the contexts work. They're sort of your reference points for your queries and your tests, so you can make decisions based on this. Anyway, I hope this made sense. We'll be continuing this in the next episode, but for now I think this is enough. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.